One ran backwards on purpose for 47 years. Another split its driving wheels into two independent groups on a rigid frame, and the engineers called it a land-bound missile. A third bolted jet engines from a Cold War bomber onto a commuter rail car and hit 1,906 miles per hour with the railroad's president sitting in the co-pilot's seat. These were not mistakes. These were deliberate, calculated acts of engineering rebellion. Here are 10 unusual locomotives that broke every rule in the book. Number 10. Southern Pacific Cab Forward AC-12. Every steam locomotive in the world puts the cab at the back behind the boiler, next to the tender. Every steam locomotive except the ones built by the Southern Pacific Railroad. For nearly 50 years, Southern Pacific operated 256 cab-forward locomotives that did exactly the opposite. They put the crew at the front, ahead of the boiler, with the smokestack behind them. The reason was survival. Southern Pacific's main line over the Sierra Nevada between Roseville, California and Sparks, Nevada had nearly 40 miles of snowsheds and 39 tunnels. When a conventional steam locomotive entered these enclosed spaces, the exhaust smoke and fumes were pushed back into the cab, suffocating the crew. Legend has it that one desperate engineer simply ran his locomotive backwards through the tunnels so the smoke would trail behind him instead of engulfing him. Southern Pacific's engineers turned that desperation into a permanent design. The cab forward was essentially a conventional 2884 articulated locomotive running in reverse. The crew sat at the front with an unobstructed view of the track. Oil fuel was piped from the tender at the rear through the length of the locomotive to the firebox at the front, which was only possible because the locomotives burned Bunker C fuel oil rather than coal. The AC-12 class, built by Baldwin Locomotive Works in 1943 and 1944, was the final and most powerful series. 20 units were constructed, numbered 4275 through 4294. These massive machines weighed over 1 million pounds with their tenders and were capable of 70 miles per hour, hauling both heavy freight and express passenger trains. Number 4294, the last cab forward built and also Southern Pacific's last new steam locomotive, is the only survivor. It is preserved at the California State Railroad Museum in Sacramento. Number 9. Pennsylvania Railroad T1 Duplex. The conventional wisdom of steam locomotive design said that if you wanted more power, you added more driving wheels to a longer, rigid frame. The Pennsylvania Railroad looked at that wisdom and said no. Instead, they split the driving wheels into two independent groups on a single rigid frame, creating the duplex locomotive, a concept that no other major railroad pursued on such a scale. The T1, designed in collaboration with Baldwin Locomotive Works and styled by legendary industrial designer Raymond Loewy, was a 4444-passenger locomotive. Two prototypes were delivered in 1942, followed by 50 production units in 1945 and The streamlined T1 looked like nothing else on the rails. Loewy's futuristic design featured a distinctive pointed nose that earned the production models the nickname Shark Nose. In testing, the T1 generated over 6,000 drawbar horsepower at speeds above 55 miles per hour, outperforming a 4-unit EMD FT diesel set rated at 5,400 horsepower at any speed above 26 miles per hour. The prototypes routinely held 100 miles per hour with trains of 13 or more passenger cars between Harrisburg and Chicago. During one test, the T1 generated 6,552 horsepower, which was 46% more than a comparable conventional locomotive with the same weight on drivers. But the duplex concept had a fatal flaw. With the driving wheels split into two groups, each group had less adhesion weight than a conventional locomotive, making the T1 prone to violent wheel slip at both low and high speeds. The complex poppet valve gear was nearly inaccessible for maintenance. By 1948, the PRR decided to dieselize its express passenger services, and by 1952, every T1 was out of service. All 52 were scrapped by 1956, and not a single one was preserved. Today, a non-profit called the T1 Trust is building a brand new T1 number 5550 from scratch, with an estimated completion date of 2030. Number 8. New York Central M497 Black Beetle. The rule was simple. Trains are powered by steam, diesel, or electricity. Nobody said anything about jet engines from a Cold War bomber. But in the summer of 1966, that is exactly what the New York Central Railroad did. And they did it in 30 days flat. The project was overseen by Don Wetzel at NYC's Technical Research Center. The team took a standard Budd RDC-3 commuter rail car, originally powered by two 2075 horsepower Detroit diesel engines, and bolted two General Electric J47-19 jet engines onto the roof at the front. These were surplus engines from a Convair B-36 Peacemaker bomber. Wetzel's wife Ruth, a commercial artist, designed the streamlined fiberglass nose cone that gave the car its aerodynamic profile. On July 23, 1966, with Wetzel as pilot and NYC President Alfred Perlman in the co-pilot seat, the M497 screamed down a 21-mile stretch of straight, unmodified track between Butler, Indiana and Stryker, Ohio. It was officially clocked at 183.85 miles per hour, setting the American rail speed record. Wetzel later revealed the speedometer had actually peaked at 196 miles per hour before he pulled back. As a safety precaution, railroad ties had been placed across the track near Toledo to derail the car if it ran away. The entire project cost a fraction of conventional high-speed rail development, using existing parts and improvised engineering. But the merger between NYC and the Pennsylvania Railroad made the data irrelevant, and the jet engines were removed. The rail car returned to ordinary commuter service and was scrapped in 1984. A commemorative plaque was dedicated at Bryan, Ohio in Number 7. Union Pacific Gas Turbine-Electric Big Blow. The rules said diesel was the future. Union Pacific said diesel was not powerful enough. While every other American railroad was buying diesel locomotives in the late 1940s and 1950s, Union Pacific went in a completely different direction. They built the largest fleet of gas turbine electric locomotives in the world. A gas turbine locomotive works like a diesel electric, except the diesel engine is replaced by a gas turbine. The advantage is enormous power from a relatively compact package. The disadvantage is enormous fuel consumption. Union Pacific solved the fuel cost problem by burning bunker C heavy fuel oil, a bottom-of-the-barrel petroleum byproduct so thick it had the consistency of tar at room temperature. It had to be heated to 200 degrees Fahrenheit before it could be pumped into the turbine. Union Pacific operated 55 gas turbine electric locomotives in 3 generations between 1948, the third-generation super turbines, delivered between 1958 and 1961, were the most powerful single-unit locomotives in the world, producing 8,500 horsepower each. Railroad workers nicknamed them Big Blows because the turbine exhaust was deafeningly loud. At their peak, the turbines hauled approximately 10% of Union Pacific's total freight traffic. The fleet was retired between 1963 and 1970, as rising fuel costs and the availability of high-horsepower diesels made them uneconomical. Soot buildup and blade erosion from the corrosive fuel also shortened turbine life. Only one third-generation unit survives at the Illinois Railway Museum. The Big Blows broke every rule about what a locomotive should burn and how loud it should be. Number 6. Chesapeake and Ohio M1 Steam Turbine-Electric. The Chesapeake and Ohio Railway did not just break the rules. They built 3 of the most bizarre-looking locomotives in history and used them to pull passenger trains. The M1 class were steam turbine electric locomotives, meaning they used a coal-fired boiler to generate steam, which drove a turbine, which spun a generator, which produced electricity for traction motors. They were steam locomotives that drove their wheels with electricity. 3 ME1s were built by Baldwin Locomotive Works and Westinghouse Electric in 1947 and 1948, numbered 500 through 502. They were enormous machines, measuring over 154 feet long with their tenders, making them among the longest steam locomotives ever built. They weighed approximately 856,000 pounds for the locomotive alone. The boiler operated at 310 pounds per square inch, and each unit was rated at 6,000 horsepower. The C&O intended to use the M1s on its passenger trains between Washington, D.C. and Cincinnati, Ohio, but the locomotives were plagued with problems from the start. They were maintenance-intensive, consumed extraordinary amounts of coal and water, and the complex turbine-electric drive system was unreliable. They were also difficult to start and sluggish at low speeds. Railroad workers gave them the nickname Sacred Cows because they cost a fortune and produced very little useful work. All three were withdrawn from service by 1950 after less than 3 years. They were stored and eventually scrapped. The M1 was a spectacular rule-breaking failure, but it proved that the idea of a turbine-electric drive was sound, even if the coal-fired steam boiler was not the right way to power it. Number 5. EMD DDA40X Centennial. The rule in diesel locomotive design was 1 engine per frame. The EMD DDA40X threw that rule out and installed 2 complete diesel engines inside a single locomotive body, creating the most powerful diesel locomotive ever built on a single frame. Each DDA40X contained 2 16-cylinder 645 E3A engines, producing a combined 6,600 horsepower. The locomotive was 98 feet 5 inches long, so massive that the frames had to be fabricated by an outside contractor because they were too large for EMD's own factory. 47 units were built exclusively for Union Pacific between 1969 and 1971, numbered 6900 through 6946. The first unit arrived in April 1969, timed to celebrate the centennial of the Transcontinental Railroad's completion, which is how the class earned its nickname. The X in the model designation stood for experimental, because the Centennial served as test beds for modular electronic control systems that were later incorporated into EMD's widely successful -2 locomotive series. Each Centennial ran approximately 2 million miles before retirement in the mid-1980s. Despite their impressive performance, the twin-engine design made maintenance complex and expensive. 13 survive today in museums and collections. Number 6936, the sole operating unit, was donated to the railroading heritage of Midwest America in 2022 and returned to operation. The DDA40X proved that 2 engines in 1 frame could work. It just was not practical enough to become standard. Number 4. British Rail Class 55. Deltic. The British Class 55 Deltic broke the rules of diesel engine design by using a power plant so unusual that most engineers had never seen anything like it. The Deltic engine, manufactured by Napier, was an opposed piston, 2-stroke diesel with a triangular arrangement of 3 crankshafts and 6 banks of opposed pistons. It was originally developed for fast Royal Navy patrol boats, and adapting it for railway use was an act of pure engineering audacity. Each Deltic locomotive contained 2 Napier Deltic D18-25 engines, producing a combined 3,300 horsepower, making them the most powerful single-unit diesel locomotives in the United Kingdom when introduced. 22 Deltics were built by English Electric at their Vulcan foundry in Newton-le-Willows between 1961 and 1962 for the eastern region of British Railways. The Deltics were assigned to the East Coast Main Line between London King's Cross and Edinburgh, where they hauled the fastest and most prestigious express passenger services. They were capable of sustained running at 100 miles per hour with heavy trains, and they transformed journey times on the route. The Deltic engine's extraordinary power-to-weight ratio gave these locomotives performance that no other British diesel could match. The engine was also notoriously complex to maintain. Each Deltic power unit had 36 pistons, 18 per engine, arranged in 3 banks of 6. The opposed piston layout meant pistons moved towards each other in each cylinder, with no cylinder heads. The triangular configuration with 3 crankshafts connected by phasing gears was mechanically fascinating but maintenance-intensive. The Deltics were withdrawn from service in 1982 when they were replaced by the Intercity 125 high-speed trains. 6 have been preserved, and several are operational on heritage railways. The Deltic broke the rules by putting a marine combat engine inside a passenger locomotive and making it work for 21 years. Number 3. French Aérotrain I-80HV. The Aérotrain did not just break the rules of locomotive design. It broke the rules of what a train was supposed to be. Developed by French engineer Jean Bertin in the 1960s, the Aérotrain was a hover train that floated on a cushion of air above a concrete guideway, propelled by a turbofan jet engine. It had no wheels, no rails, and no conventional drive system. The most advanced prototype, the I-80HV, was designed to carry 80 passengers at speeds exceeding 200 miles per hour. On March 5, 1974, it reached 267 miles per hour on an 11.2-mile test track near Orléans, setting the record for the fastest air cushion vehicle on land. The French government was so impressed that it awarded Bertin a commercial contract to build a passenger line connecting Cergy and La Défense near Paris. But the dream collapsed quickly. In September 1975, France's National Railway SNCF declared that conventional electric traction was the future of its high-speed program, which would become the TGV. Less than 4 weeks after the Aérotrain contract was signed, it was cancelled. On December 21, 1975, Bertin died of a brain tumor at the age of 58. The I-80HV made its final test run in late 1977 before being retired to its hangar. In 1992, it was destroyed by arson. The Aérotrain proved that a vehicle could travel at extraordinary speeds on a cushion of air over a concrete track. The technology worked, but France chose electric steel-on-steel rail instead, and the Aérotrain became one of the most brilliant dead ends in transportation history. Number 2. Pennsylvania Railroad, Q2 Duplex. The Pennsylvania Railroad's Q2 broke the rules of steam locomotive power and holds a record that has never been equaled. During testing at the PRR's Altoona test plant in the spring of 1945, Q2 number 6175 produced 7,987 indicated cylinder horsepower. That is the highest horsepower figure ever recorded for any steam locomotive on a static test plant. The Q2 was a 4464 duplex freight locomotive, the largest non-articulated locomotive ever built. 26 units were constructed at the PRR's Juniata shops between 1944 and 1945. The duplex design split the driving wheels into 2 independent groups with 4 leading wheels, 4 driving wheels in the forward group, 6 driving wheels in the rear group, and 4 trailing wheels. This arrangement gave the Q2 10 driving wheels powered by 4 cylinders on a single rigid frame. With 115 800-pounds of tractive effort, the PRR claimed a Q2 could haul 125 freight cars at 50 miles per hour. It was 78% more powerful than any previous PRR freight locomotive. In operation, the Q2 could outperform existing engines by hauling double the tonnage. Despite this extraordinary power, the Q2 was born too late. Diesels were cheaper to operate and maintain, and the complex duplex drive system was expensive and difficult to service. All Q2s were out of service by 1951 and scrapped by 1956. Not a single one was preserved. All that remains are 2 number plates and a builder's plate, the only physical evidence that the most powerful rigid-frame steam locomotive ever built once existed. Number 1. Norfolk and Western Y6b. Our number 1 spot goes to a locomotive that broke what was perhaps the biggest rule of all, the rule that said steam was finished. In 1948, while every other major American railroad was rushing to buy diesel locomotives, the Norfolk and Western Railway was still building brand-new steam locomotives at its Roanoke shops in Virginia. And the machines they built, the Y6b Class 2882 compound articulated locomotives, were among the most powerful ever constructed. The Y6b was designed for one of the toughest jobs in American railroading, dragging loaded coal trains over the steep grades of the Appalachian Mountains. In compound mode, the Y6b produced 106 pounds of starting tractive effort, which was among the highest figures ever achieved by any steam locomotive. These were slow-speed, high-torque machines designed to grind up mountain grades at 10 to 15 miles per hour with enormous loads. The Norfolk and Western built the Y6b class because they genuinely believed steam was still the right answer for their specific operating conditions. They had cheap coal from their own lines, expert shop forces who could build steam locomotives more efficiently than anyone else in the country, and a system designed from top to bottom for steam operations. The N&W ran 3 classes of mainline steam in the 1950s, the Class A 22664 for fast freight, the Class J 484 for passengers, and the Y6 for heavy coal service. Together they were the finest fleet of modern steam locomotives in the world. The last Y6b was completed in 1952, making them among the very last mainline steam locomotives built in the United States for domestic service. They served until 1960, outlasting steam on virtually every other American railroad. Number 256, the final steam locomotive built by the N&W, is preserved at the National Museum of Transportation in St. Louis. The Norfolk and Western Y6b broke the ultimate rule. The rule that said the age of steam was over. For more than a decade, while the rest of America ran diesel, the N&W proved that a well-designed, well-maintained steam locomotive could still earn its keep. They were the last rebels of the steam age, and they went down fighting. If you enjoyed this video, hit that like button, subscribe to the channel, and drop a comment below telling me which rule breaker impressed you the most. I will see you in the next one.